Our main focus for today is physics. We are looking at electric circuits. This will be lesson 101. Let us start. In electric circuits, this is what you should know. We have different types of symbols that we use when we draw electric circuits. Now this represents our battery. A battery consists of cells, so we know that this represents one cell. Then if we have more than one cell, we actually have a battery. So this symbol represents a battery. And then moving to the next symbol, this represents voltmeter. It measures a voltage. So since we connected across this, it simply measures the voltage which is produced by this battery. Moving to the next symbol, this is what we call the resistor. It has the resistance measured in ohms. Oh, by the way, the voltmeter measures voltage, which the SI unit is volts. And then resistance, actually resistor has a resistance which is measured in ohms. And then the next symbol is the ammeter, which measures the current. The SI unit of current is amperes. And then the rest of this diagram, like this, we call them connecting wires. So basically this is what you must know. Let us go straight to different types of circuits. We have two different types of electric circuits. The first one is series connection, the second one is parallel connection. Now we normally refer to resistors. We look at the connection of resistors in order for us to say a particular circuit is a parallel or a series connection. Now looking at the series connection, we can see that we have R1 and R2, which is our resistors, and then you can see the manner which they are connected. There's no branch. The reason why we say it's series, they are connected on one conducting wire. Now looking at parallel connection, we can see that we have a branch. We refer this as a parallel connection. We say the two resistors are parallel to each other. For this one, we say the two resistors are in series. Now looking at the direction of the current, before we look at the direction of current, the symbol of a cell, the longer line represents a positive terminal, then the shorter one represents a negative terminal. So you should know that always the direction of the current moves from positive to negative. So it simply means that when you look at this series connection, the direction of the current will be this direction. Looking at the parallel connection, but there's something that you need to know. When it comes to parallel connection, the moment it reaches this junction, the current will split. Part of the current will go through R1, the other one will go through R2, and then they meet up on this second junction, they add up, and then they go straight to the negative terminal. We will discuss this in detail. So this is what you need to know about different types of connection. Let us quickly discuss the equations. Simply write these equations, and then we are going to look at the application of these equations. Under series connection, you should know that V total means the total voltage produced by this power supply. It's equals to V1 voltage across R1 plus V2 voltage across R2. So in order for us to get this total voltage, we need the sum of potential difference across these two resistors. Now V total in parallel connection, V1 is equals to V2. So it simply means that the total voltage across or supplied by the battery will be equals to the total potential difference across R1, total potential across R2. So it simply means that if, let's say, we have 3 volts from the battery produces 3 volts, it means the voltage across R1 will be 3 volts, the voltage across R2 will also be 3 volts. Now looking at the current, the total current is equals to the current across R1 equals to the current across R2. Looking at, actually let us explain this. Suppose the total current is 3 amperes. It means the current through R1 will be 3 amperes. The current through R2 will also be 3 amperes, provided the connection is series only. Now looking at the second connection, the total current is equals to I1 plus I2. So if our current is 3 amperes, it means our current will move from the positive terminal. When it reaches this point, it will divide, like I said, and then some of the current will pass through R1 and then the other part will pass through R2. So it simply means that if you are looking for the total current, we need the sum of the two currents. Now the last part, or the last physical quantity that we're dealing with, we have the resistance. So if you are looking for the total resistance in series connection, we're simply going to take the sum of the two. Now looking at the parallel connection, actually this equation continues up to Rn. Now to calculate the resistance in parallel connection, we are going to take the fraction 1 over the value of the resistance plus 1 over the value of the resistance. Now in this lesson video, we are going to close it up with the calculation of resistance, and then looking at lesson 102, we are going to look at another physical quantity. It might be the potential difference or the current. Now let us look at examples on how to apply these equations. Our first example, we have this type of connection. The question says calculate the effective resistance of the circuit or the total resistance of the circuit. Now we look at this type of a connection, we can see that this is a series connection. So we are going to use this equation. Since we have 3 resistors, we are going to end at 3. So the first resistance of R1 is 3. Alright, this is R1, this is R2, this is R3. So we have 3 ohms plus 2 ohms plus 7 ohms. And then we are going to have 12 ohms. So the effective resistance of this circuit is 12 ohms. We can also say this is the total resistance, which is 12 ohms. Another question. Feel free to pause the video and calculate the effective resistance. Now we can see that the connection is still series connection. So R1 is 6 plus 4. We are going to have 10 ohms. That is the effective resistance. Another example, feel free to pause the video and work out this question. The effective resistance will be R1 plus R2 plus R3. So we are going to have 4 plus 3 plus 5. This will be 12 ohms. We can see that this one is a bit different from the previous examples. This one is a parallel connection. The moment you see a branch, just know that it's a parallel connection. The current will flow from positive terminal. When it reaches this point, it will divide. So since we can see that we have two paths where the current will go through, then we can confirm that this is a parallel connection. Then the equation to calculate parallel connection is this one, and then 1 over the magnitude of the first resistor is 1 plus the second one is 3. So this is 1 over R parallel. So 1 over 1 plus 1 over 3 is 4 over 3, 1 over R parallel. We are looking for R parallel, not 1 over R parallel, so we need to cross multiply. So it's 4 multiplied by R parallel, we have 4R parallel. 1 multiplied by 3, we have 3. Divide by 4 both sides. And then R parallel is equals to 3 over 4 ohms. That is the effective resistance of the circuit. Basically, we are simply reducing this or combining the two resistance. So if you want to draw a new circuit, we can draw it like this. We no longer have a parallel connection, and then this one will be 3 over 4 ohms. So basically, we are trying to reduce the number of resistance. Let us look at this example. We can see that we have a parallel connection consisting of 3 resistors. So it will be 1 over R parallel is equals to 1 over R1 plus 1 over R2 plus 1 over R3. 1 over R parallel is equals to 1 over 2 plus 1 over 3 plus 1 over 4. 1 over R parallel is equals to, we get that the sum of these 3 fractions, we get 13 over 12. And then from there, we can just flip this fraction. We take this one, we bring it to the numerator, take this one to the denominator. So it becomes R parallel over 1, which is the same as R parallel. It's equals to, what we do on the left, we must do on the right. So we flip also this one to have 12 over 13 ohms. So this is the effective resistance. Let us look at this example. Now this one is a bit different. We have the combination of 2 connections on one circuit. So looking at the direction of the current, it will move this direction, goes through this 7 ohms resistor. You can see that before the 7 ohm resistor, there is no junction or branch. So we can confirm that this is series connection. Now continuing with the direction of the current, when it reaches this junction, before it goes to this resistor, there is a junction or a branch. So it will split, another branch, it splits. So these 3 resistors, they are connected in parallel. So how do we calculate the effective resistance when we have two combination or combination of connections. Now in this case we need to reduce one connection, so we are going to start calculating the effective resistance on the parallel connection. We are going to reduce these three resistors to become one resistor. So it will be 1 over R parallel is equals to 1 over R1 plus 1 over R2 plus 1 over R3. 1 over R parallel is equals to 1 over, we take this as R1. R1 is 2, 6, 4. 2 over 3. So flipping this, R parallel is 3 over 2. So we can quickly draw a new circuit diagram. We are going to have something like this. This is 7 ohms, and then this is 3 over 2 ohms. And then from here, we can calculate the resistance again. Now we no longer have parallel connection, so we go ahead and calculate the series connection. So it's 7 plus 3 over 2. We get that our series connection is 23 over 3 ohms. Let us look at another example. Looking at this example, in order for us to identify the series connection and the parallel, we need to look at the direction of the current. So we can see that before these two resistors we have a junction, so we can confirm that the two, they are parallel. And then we continue, they meet up here, and then the sum of the two current flowing through each resistor, which is 3 and 4, will go through the one resistor. So this one is series connection. Then we can take it from there. We solve for the resistance across the parallel using our equation. So we have 1 over 3 plus 1 over 4, which will be 7 over 12. Then when we flip, we are going to have R parallel is equals to 7, no, it's actually 12 over 7 ohms. And then from here, redrawing this, we are going to have something like this. So this will be 12 over 7, and then this will be 1 ohms. Now we can use the series connection, R1 plus R2, 12 over 7 plus 1. This will be the same as 7 over 7, so we take 1 denominator, and then 7 plus 12, it's 19, so it's 19 ohms. Let us look at another example. This one is a bit different. Let us identify the connections. This will be the direction of the current. So you can see there's no junction before this resistor. So this one is in series. Now continuing, we have a junction, it separates, it splits. Now we can see that on the second branch, this branch, we have two resistors again connected in series. So looking at the two, let me actually use a different color. Looking at the two, this one they are connected in series, but it's on a branch. The two, they are connected parallel to this one. So within a branch, within a parallel connection, we have a series connection again. So we need to be careful when we are calculating. So where is the starting point? We cannot just calculate the parallel connection. We need to solve this series connection first. So we are going to use series equation. It's 3 plus 7. We have 10 ohms. So when we redraw this, we are going to have something like this. Two ohms, and then this one is no longer 3 and 7, it's 10 ohms and 6 ohms. Then from here, we need to solve this. We are going to have R, actually 1 over R parallel is equals to 1 over R1 plus 1 over R2. 1 over R parallel is equals to 1 over 10 plus 1 over 6. That will be 4 over 15. Flipping this, you are going to have 15 over 4. Now redrawing the circuit again, we are going to have something like this. We no longer have a parallel connection, so it's 15 over 4 and 2. Then from here, we are going to use the series connection, which will be 2 plus 15 over 4. Now you know that 2 is the same as 4 over, actually 8 over 4 plus 15 over 4. So from here we can take one denominator, then 8 plus 15, we are going to have 23. That's it for this lesson video. This is Wahula SJ. Thank you very much.